So hello my dear students, today is our next class. So in this class we are going to see how to convert a given Boolean function into canonical product of some form. In our previous video we have seen what is meant by a canonical expression, what is meant by sum of products form, what is meant by product of sum form. So let's revise it once. Before that we should know what is min term and what is max term. So what is a min term? Min term is product of all the literals in a given expression. What is an literal? Literal is nothing but a single logical variable. Say for example x or y or z. Okay. So min term is product of all the literals. And what is max term? Max term is sum of all the literals present in a given Boolean expression. Okay. Then we have seen what is a canonical expression. What is a canonical expression? It is a Boolean expression which is either made entirely with the help of min terms or it is made entirely with the help of max terms. So I repeat, what is a canonical expression? It is nothing but a Boolean expression which is made up either entirely of min terms or of max terms. Okay. And under canonical expressions we have seen there are two forms. One is sum of products, another is product of sum. In our previous video we have seen sum of products. What is a sum of product canonical expression? It is nothing but a Boolean expression which is completely made up of min terms. Okay. Then what is product of sum form then? This is also the canonical expression or the Boolean expression which is made up of completely max terms. Okay. Then in our previous videos or classes we have also seen how to expand the min term expression and max term expression. So when we are expanding a min term expression, if any literal is missing in a term, then what we are doing? We are multiplying with the missing literal plus complement of missing literal. Similarly, when we are going to expand a max term expression, at that time we have seen how to add a missing literal. That is, we add the missing literal into complement of missing literal. So now let us begin with the today's concept, that is converting the given Boolean function into canonical product of some form. So let us start with an example for today, which is x plus y into y plus z. So whenever an expression is given and now you have to convert it into completely canonical product of some form, so you have to check in each term whether any literal is missing. Okay. So let's start with the first term. You are having x plus y and here you are having second term y plus z. Now in this entire expression we have to check totally how many different literals are used. So we have used here x, we have used y and we have used z in the complete expression. Right. So let's consider the first term over here. In this first term z is missing and in this second term x is missing. So how do we add it? As I just revised the concept of expansion of max terms, what we exactly do? We add the missing literal into complement of missing literal. So see the next step, I am taking this term x plus y plus, what is missing here? Z is missing over here. So we say z into complement of z. Okay. Coming to next term, you have y plus z and in this particular term we are having x missing. So we say x into x complement. Okay. Now after adding the missing literal we need to expand it. So how to expand? To expand I will be using the distributive law x plus yz. So what exactly this distributive law says? X plus yz. It says x plus yz results in x plus y into x plus z. So same we can apply here. I take this as x and this is taken as yz. Okay. So now apply the distributive law. X plus y, which means x plus y plus z, then x plus y plus z complement. Similarly, I should apply here also now the distributive law x plus yz. So it will be again x plus y plus z, then x complement plus y plus z. Okay. Now after we expand the term, again we should check each term, whether in each term all the literals are present. Which are those literals? X, y, z. So check the first one, it is there. Second one, it is there. See, the missing literal can be in the original form or it can be in the complemented form, but it should be present in that term. So here you are having the complemented form of z. So all the three literals are there. Here you have x, y, z, done. Then you are having x complement plus y plus z, okay. So here this is an entire expression where each term is having all the literals. Okay. Now after expanding that particular expression, we have to check whether there is any repeated term. So as we can observe, we are having the repeated term x plus y plus z, x plus y plus z. So we have to discard one term and then write the final expression. Now you have x plus y plus z into x plus y plus z complement into, this is the repeated term, discard, right, x complement plus y plus z. Okay. So this is the final expression which has arrived. After we get this final expression, now we have to write its shorthand notation. So as we have seen earlier, if it is a max term and then the original literal, if it is x, y and z, it will be holding value 0. If it is the complemented form, it means that it is holding value 1 for max terms. So now it will be 0, 0, 0. That is why it is m naught. And for max term, we are using uppercase m. Okay. Next, here again it is 0, 0. Since it is complemented, it is 1. So 0, 0, 1 means m1. That is a value here. Now here it is 1, 0, 0. So 1, 0, 0 is the binary form for decimal 4. So I am writing m4. Okay. After writing its max term designations, next you have to write the final expression, function of what are the three literals x, y, z, mention them, equals. When it comes to product of sum form, we use the symbol pi as the shorthand form, and then we have to write what are the three decimal values associated with the terms. They are 0, 1, 4. The same I have mentioned here, 0, 1, 4. Okay. So this is how we convert the given Boolean function into canonical product of sum form. Okay. Now let us move to the next example, wherein again we are going to convert the given Boolean function into canonical product of sum form. Now let us take the next example, which says AB plus A complement C. Now this has to be converted into canonical product of sum form. But if you observe, it is not in the form of max terms, right? Now this particular expression which is given, it is not in the form of max term. So how to convert it? So before we start getting the product of sum form, first we have to convert it into max term form. So now just see, take this term AB plus A complement C, apply again distributive law, which says x plus yz results in x plus y, x plus z. So they consider this as x and this is yz. Now we have to split it. So it will be ab plus a complement, again ab plus c. Okay. Now after getting this, again we have to apply here distributive law. So it will be again x plus yz, which means x plus y, x plus z. So now this will be x and these are yz. Okay. So again you apply a complement plus b, a complement plus a. Okay. Now here again you apply same way. So it will be a plus c, b plus c. So we have split it using distributive law. So now you see you are getting a form here. Okay. Now with this particular expression we have to check the later steps. First write a complement plus b as it is. Then you take a plus a complement. A plus a complement results in 1. That is by complementarity law. Next, you write a plus c, b plus c. So now we get here an expression. Now with the help of this expression we can convert to product of sum form. Now check the entire expression. How many different literals are being used here? So as you see, we have A, B and C over here. So check whether all the terms are having these literals. Let's take the first term, which is A complement plus B. So here what is missing? C is missing. Then take A plus C. What is missing? B. Then take B plus C. So again here missing is A. So let's take one term at a time and expand it. So I have taken now first one, A complement plus B. So what is missing? C. So I say plus C into C complement. Okay. Now expand it. How to expand this particular expression now? We have to again apply distributive law. So after applying the distributive law, you get A complement plus B plus C. Then you get A complement plus B plus C complement. Okay. Take the next term here. So it says A plus C plus B into B complement. Now you expand it. A plus C plus B. So A plus B plus C you are going to get here. Next A plus B complement plus C. Take the next one, which is B plus C. So here what is missing? A is missing. So say plus A into A complement. Now again apply distributive law and expand it, which is A plus B plus C, then A complement plus B plus C. Okay. Next, we have got the different terms over here. So after getting those terms, we have to write the final expression. So you are having A complement plus B plus C, which comes here. Then A complement plus B plus C complement. Then A plus B plus C. Then A plus B complement plus C. Again you are having A plus B plus C, so this is a repeated term, discard it. Then you are having A complement plus B plus C, this is also a repeated term, discard it. So finally you are getting the final expression with these four terms. Next, after writing this final expression, we have to next check here. A complement means it is holding 1. These are zeros. So here again it is 1, 0, 1. So it will be 0, 0, 0, 0, 1, 0. Okay. Now 1, 0, 0 means it is 4. So take uppercase M with 4 as the value here. 1, 0, 1 is 5. So M5. 0, 0, 0 is M0. Then 0, 1, 0 is M2. Then write, therefore, function of A, B, C, because those are the three literals which are present over here. F or function of ABC pi, write these different decimal values in the ascending order. So it is 0, 2, 4, 5. So this is how we are going to convert the given Boolean function into the canonical product of sum form. Okay. So I hope students you are clear with how to convert the given Boolean function into canonical product of sum form. Now we'll see some important problems which are associated with these min terms and max terms. So now let us start with our first problem, that is, it says, what are the fundamental products for each of the input words? Here fundamental products means it is min term. Okay. Input words means these values of zeros and ones. Okay. So the question says, what are the fundamental products for each of the input words? That is, the first one, we have four literals A, B, C, D which are holding the values 0, 0, 1, 0. Then we have another one A, B, C, D holding the value 0, 1, 1, 0. The next problem A, B, C, D with the value 1, 1, 1, 0. Then the question says, write sum of products expression. So how exactly we have to solve this particular problem? Say solution. Take the first input word, that is A, B, C, D, which is holding the value 0, 0, 1, 0. Okay. If it is a min term and if a particular literal is holding the value 0, which means it should be in its complemented form. If upper literal is holding the value 1, it means that it should be the original term itself. So now according to this, A is holding 0, so it should be A complement. B is holding 0, it is B complement. C is holding 1, so it remains as it is C. D is holding 0, so it will be D complement. Okay. Let's take the next one, A, B, C, D with the value 0, 1, 1, 0. Now we have to write the min term for it. A is holding the value 0, so it will be A complement. B is holding value 1, so it will be B as it is. C is holding value 1, it will be kept as it. D is holding value 0, so it will be D complement. Now let's take the next one, A, B, C, D with the value 1, 1, 1, 0. Now let's write the min term. A is holding the value 1, so A as it is. B is holding 1, B. C is holding 1, C. D is holding value 0, so it will be D complement. So here we have got three different min terms. Now with the help of these three min terms, we have to write the final sum of product expression as it is asked in the question. Therefore, sum of product expression will be A complement, B complement, C, D complement, that is the first one, plus A complement, B, C, D complement, the second one, then A, B, C, D complement, which is the third term. So this is how, if a question is asked, write the fundamental products by giving the input values, how to write the sum of products expression. Okay. Now coming to the next problem. It says, a truth table has output 1 for each of these inputs. So what are those inputs? A, B, C, D with the input 0, 0, 1, 1. A, B, C, D with 0, 1, 0, 1. A, B, C, D with 1, 0, 0, 0. Then it says in the question, what are the fundamental products and write min term expression. So min term expression is nothing but your sum of products expression, following the same procedure as we have done for the previous problem. So write the fundamental products first. Say first one, A, B, C, D holding 0, 1, 0, 1, this particular term. So if A is holding 0, should be A complement. B is holding 1, B as it is. C is holding 0, C complement. D is holding 1, D as it is. Then take the next A, B, C, D, which is holding 1, 0, 0. A is holding 1, keep A as it is. B is holding 0, B complement. C is holding 0, C complement. D is holding 0, D complement. Then we have A, B, C, D, 0, 0, 1, 1. Okay. So now A is holding 0, so it will be A complement. B is holding 0, it is going to be B complement. C is holding 1, it will be C as it is. D is holding 1, it will be D as it is. Okay. So now we have got here the 3 minterms or the fundamental products. So with the help of these 3 minterms, we will be writing the final minterm expression as A complement B, C complement D, the first one, plus A complement B complement A, B complement C complement D complement, which is the second one, plus A complement B complement C D, which is the third term. So given the question to find the fundamental products and to write the sum of products expression, this is how we are going to solve it. I hope you are clear. Now moving on to the next set of problems. Next. Now the next problem says construct a Boolean function of 3 variables x, y and z. Okay, see the question properly. Construct a Boolean function of 3 variables x, y and z that has an output 1. Okay, the truth table or the Boolean function is going to have the output 1 when exactly 2 of, that is out of the 3 literals, exactly 2 of x, y, z are having values 0 and an output 0 in all other cases. Okay. So the term will result into the true value if exactly the 2 of x, y, z is holding value 0. That means out of the 3 literals x, y and z, there exactly 2 should hold the value 0 and the third one should hold the value as 1. So let's see the possibilities here. So starting with x, y, z, x is 0, y is 0. So what question says exactly 2 should hold 0 value, which means now z will become 1. Now here I have taken x0, z0. Okay, so y should become 1. Here I have taken y0, z0. X becomes 1 over here. So as per the question, out of the 3 literals given, 2 exactly should hold value 0. Then only those terms can be considered to construct the final Boolean function. Okay. So now as per this value, if x is holding 0, it will be x complement. Okay. Y is holding 0, it will be y complement. Z is holding 1, it will be z. Take next. X is holding 0, x complement. Y is holding 1, it remains y as it is. Z is holding 0, it will be z complement. Next one. X is holding 1, it will be x. Y is holding 0, y complement. Z is holding 0, it will be z complement. Okay. Now with the help of these 3 minterms, we have to write this final given expression. So now you see it is x complement, y complement, z. This should be x complement, y, z complement plus x, y complement, z complement. Okay. So here it cannot be a max term. It has to be a min term only. So you get the final expression x complement, y complement, z plus x complement, y, z complement plus x, y complement, z complement. So in the question it was given, out of the 3 literals, exactly 2 should hold 0 and the third one should hold 1. Only then it can be considered for constructing the final Boolean expression. So this is how the Boolean expression has been constructed here. Now moving to the next example, which says, construct a truth table for 3 variables A, B, C that will have an output 1. So a truth table with the 3 variables is going to have the output 1 when x, y, z is holding 1, 0, 0, x, y, z is holding 1, 0, 1, x, y, z is holding 1, 1, 0, x, y, z is holding 1, 1, 1. Then we have to write the Boolean expression for sum of product form. So here they have given very clearly in the question what are the different terms which are resulting in 1 in the truth table. So now let's take the first one, which says x, y, z is holding 1, 0, 0. So now x is holding 1, so the term literal will be as it is x. Y is holding 0, it will be y complement. Z is holding 0, it is going to be z complement. Now let's take the next one. X, y, z, it is holding 1, 0, 1. So now x is holding 1, so it remains x as it is. Y is holding 0, it will be y complement. Z is holding 1, it is going to be z. Next, x, y, z resulting 1, 1, 0. So now x is holding 1, so it is x as it is. Y is holding 1, it results in y as it is. Z is holding 0, it becomes z complement. Now take the next one, x, y, z resulting in 1, 1, 1. So all the 3 literals are holding value as 1, so it results x, y, z itself. So here we have got all the min terms which are required for constructing the final sum of product expression. Therefore the final sum of product form is x, y complement, z complement, this is first term, plus x, y complement, z, which is the second term, plus x, y, z complement, which is the third term, then plus x, y, z, which is fourth term. Okay, so I hope you are clear with this problem. Now moving on to the next problem, which is convert the given sum of product form to product of sum form. So in this question you will be given the terms which are sum of product, that is which are min terms. So with the help of those you have to construct the max term and write the final product of sum expression. How do we convert it is, now take the question which says function of x, y, z equals summation. Summation is the sign used for sum of product form. 0, 1, 3, 5. Okay. If there are 3 literals, so totally how many combination of values will come? We get totally 8 combination of values, which means it starts from 0 to 7. So for our sum of product form, we have got 0, 1, 3, 5. So apart from these 4, the remaining terms which are there from 0 to 7 are our max terms. So it is summation 0, 1, 3, 5. So if 0 is here, it cannot be there under max term. 1 is here, it cannot be there under max term. See, for product of sum form we use pi symbol. Here 2 is not there, which means 2 comes under max term. Then we have 3, so 3 cannot be considered under max term. We don't have 4 here, so it comes under max term here. Next you have 5, which cannot be considered under max term. Then we are left out with 6 and 7 comes under max term here. So whenever you are converting the given sum of product form to product of sum form or vice versa, students always remember, if a particular term is shown under sum of product form, the remaining will be for product of sum. If a particular term is shown under product of sum form, the remaining terms will be shown under sum of product form. So here 0, 1, 3, 5 are min terms, then the remaining ones from 0 to 7 will be under max terms. Okay. So now we have got here. Now let's construct the product of sum form with the help of this given data. So now it says 2. So under max term we use the shorthand notation capital M. So take M2 equals, since there are 3 literals, we have to show in terms of 3 combination of binary values. 2 in binary form is shown as 0, 1, 0. Okay. So under max terms, if it is 0, which means it is the original term, we have to write. If it is 1, we have to write under complemented form. So now 0, so the x is going to be as it is, plus next y we are having, which is holding value 1, so it will be y complement, plus 0 means it is z as it is. Okay. Next, take the next one, M4. 4 binary value is 1, 0, 0. If it is 1, so it should be in complemented form. If it is 0, it will be the original form. So the first one x holding 1, x complement. Next 2 are zeros, so they will be written as it is y plus z. Next take M6. 6 is shown in the binary form as double 1, 0. So 2 are shown in terms of 1, so it will be x complement plus y complement, then 0 is plus z. Okay. Last one M7. 7 is indicated in the binary form as 111 equals, see all the 3 are 1, so it should be in the complemented form only, x complement plus y complement plus z complement. So now we have got 4 different max terms here. Now using these max terms, we have to construct the final product of sum form expression. So here x plus y complement plus z, the first term, into x complement plus y plus z, second term, into x complement plus y complement plus z, which is the third term. Then you have x complement plus y complement plus z complement, which is the last term. So this is how we convert the given sum of product form to product of sum form. Okay. Now moving on to the next problem, which says convert the following product of sum form into corresponding sum of product form. So just in the previous example we have seen how to convert sum of product to product of sum, vice versa. Okay. So here they have given the product of sum form, we have to convert it into sum of product form. Now let's take the example function xyz. So again there are 3 literals. If there are 3 literals, so we are going to get totally 8 combination of values. So pi indicates product of sum, it is holding 2, 4, 6, 7. So if 2, 4, 6, 7 are under product of sum, then the remaining will be for sum of products form. So let's write first which are those values. Function of xyz equals product of sum 2, 4, 6, 7. So if there are 3 literals, we get 8 combination which begins from 0 to 7. So let's start. We don't have 0 here, which means it comes under sum of products. We don't have 1, it comes under sum of products. 2 is here, we cannot consider it here. 3 is not present, so it comes under sum of product form. 4 present here, so we cannot consider here. 5 is not present, so it comes under sum of products form. 6 and 7 are under product of sum form. So the ones which are present in product of sum form cannot be considered under sum of product form. So the remaining ones have come under sum of product forms. Okay. So now let's start writing the min terms and then we'll write the final expression. Take 0. So under our min terms we are using the shorthand notations lowercase m. So m naught. M naught means there are 3 literals, so we have to show binary value in 3 different forms, 0, 0, 0. So under the min terms, if a particular literal is holding the value 0, it will be in its complemented form. If it is holding the value 1, it is the original form. So now 0, 0, 0, which means x complement, y complement, z complement. Next we are having M1, binary form is 0, 0, 1. So we have x complement, y complement, z. Then take M3, 3 is indicated 0, 1, 1 in binary form. So it will be x complement, y, z. Next we have 5. So binary form is 1, 0, 1. So we write x, y complement, z. So now we have got finally the 4 different min terms over here. So with the help of these min terms, we will finally construct the sum of products form. So it is x complement, y complement, z complement plus x complement, y complement, z plus x complement, yz plus x, y complement, z. Okay. So this is how we convert the given product of sum form to sum of products form. So students, I hope you are clear with the today's concepts of how to convert the given Boolean function into canonical product of sum form. Then the different varieties of problems which can be asked in terms of min terms and max terms. So all the students, please clearly and carefully go through the complete video, and then based on this video you will be receiving the assignment and the materials. So kindly solve the assignment in the book which you have maintained for CS. Okay. So I hope you are clear with all the concepts for today. Thank you.